Hi guys, this is Miss Raina coming to you from C347 at MacArthur High School. I want to talk to you about straight up motion, so projectile motion going straight up and down. Talk to me about what's going on in this picture, what's wrong with this picture right here. It's supposed to be a depiction of a projectile being shot straight up in the air and falling straight back down, and if you say that the path on the way down should be exactly the same way as the path on the way up, you're right. The thing is that this is being altered a little bit so that you can visualize the object going on its way down and on its way up at the same time. So follow along with me in your notes. Remember that velocity, displacement, and acceleration are all vector quantities. They all have signs, and the signs tell the direction, since a vector needs a magnitude and a direction. What do the signs mean? If they're positive, it means up. If they're negative, it means down. We have a new word starting the beginning of next unit, so we're just going to get a little bit ahead. X component means the parts of a vector that are going in the horizontal direction, and Y component means only the vertical parts of a certain motion. So if we throw a ball straight up and down, you and me know that it doesn't actually look like this, that the ball actually falls straight back down to this guy's hand. There should be no motion in the X direction. So here's a look at the equations. We're going to use exactly the same as before. We're going to insert a little y subscript when we need it next unit, when we start to do projectile motion in both directions. In every case, all it means is displacement in the y direction, velocity in the y direction, final velocity in the y direction. So don't freak out if you start to see those little subscripts, those y's in class. We're not going to break down those vectors because they're exactly the same up and down. I'm sorry, meaning the x component is exactly the same up and down at 0. I do want to point out, however, that for every second that the object spends traveling upward, it's losing 10 meters per second. For every second that it spends traveling downward, it's gaining 10 meters per second. So at every corresponding point here, the speeds are identical. In other words, the magnitudes here are the same number. So if you know the initial velocity on the way up, don't worry about doing a crisscross and solving the problem. You should know the final velocity as it hits its final spot on the way down. Okay, so let's see if we can figure out an equation that tells us how long it takes to get to the top of a trajectory. And what I want you to focus on here is this word top. So we should know that the top of a trajectory is specifically telling us that the velocity up here is going to be 0. Now it used to be that when we were doing just plain old free fall where something just fell, we said our initial velocity is always 0, and we can't say the initial velocity is always 0 anymore, because sometimes things start from down here in the trajectory. You can always say that the velocity in the y direction at the top is always going to be 0 meters per second. So let's use that to our advantage. When they ask us how long, they want to know the time. So let's use this little spot over here so we can kind of illustrate what's going on. The other thing you know is gravity is negative 9.8 meters per second squared. If I'm trying to figure out the time it takes to get to the top, and they've given me the initial velocity, I know the final velocity is 0. I know that I'm going to need an equation that uses t and that uses g or a, acceleration due to gravity. Then I'm going to choose this one. The final velocity is the initial velocity plus acceleration times time. From there, all I'm going to do is manipulate it algebraically so that I can get my time by itself. And I'm really sorry about those flashing letters. So just rewriting and canceling out my v initial, I can see all I have left to do is cancel out my acceleration due to gravity. Once I do that and rewrite, I should end up with a good formula for time, and that's going to equal final velocity minus initial velocity divided by my acceleration due to gravity. There you have it. Okay, let's try another one. So let's say I want to know how long it stays in the air. Well, the total time in the air is going to come from how long did it take to get to the top. If I know how long it took to get to the top, Remember I told you the velocities on the way up, the speeds on the way up and the speeds on the way down are identical? The time on the way up and the time on the way down is also identical. So if I want to know the total time in the air, all I have to do is double the time that it took to get to the top. Keep that in mind because sometimes they'll give you the total time in the air and you'll have to figure out, the other way, how long did it take to get to the top. So how high is it going to go? Again, you need to keep in mind that the velocity here at the top is 0. Let's say they gave you the initial velocity, and so if we want to know the distance that it went, let's use the equation that will allow us to use all the variables that we know. Sorry, that should be a negative 9.8. Alright, so that tells me that I'm going to need this equation, v final squared equals v initial squared plus 2ad. And I'm using these letters interchangeably. Sometimes I use a G and sometimes I use an A, and that's on purpose. So I've got to get, let's see, my distance all by itself. So what I'm going to do first is eliminate that v initial, just rewriting. I'll get v final squared minus v initial squared equals 2ad. Now I've got to eliminate the 2 and the a, so I can leave the d by itself. So I'll divide by 2a on both sides. Canceling and rewriting, I can tell that my v final minus my v initial, each of those squared, divided by 2a is going to give me a good formula to get the distance all the way to the top. That'll tell me how high it's going to go from my initial velocity that was given to me to a final velocity of 0, because I know that that's what's going to happen at the top of the trajectory. So let's take an example here. I'm going to skip this one because this is a lot like the one that we did in class. Instead, let's do our example number 2. So let's say I'm trying to figure out how fast with what speed. So that's telling me to calculate initial velocity. Does it have to be thrown vertically? That tells me that this is going to be in the y direction. To reach a maximum height, that's a distance of 50 meters. And additionally, they want to know how long is it going to be in the air. So they're asking me to figure out a time. All right. So far, I know that the velocity at the top of the trajectory, so my final velocity is going to be 0 meters per second. I also know that acceleration due to gravity is going to be negative 9.8 meters per second squared. I know that the distance traveled is 50 meters. So I need to use that to help me figure out with what speed, with what final velocity it's going to hit at the top. It has to be thrown at. So I need initial velocity. And I'm also supposed to figure out how long it's going to spend in the air. So let's take a look at these first variables that I'm going to need to use. That tells me to pick the equation that has my v final. It also has my v initial and acceleration and time and distance. I got to solve this for v initial, so this time I'm actually going to subtract 2ad from each side. So I can cancel out this term and leave my v initial squared by itself. I'll end up with v final squared minus, 2ad, and that'll equal my v initial squared. Well, it looks like it's isolated, but it's not yet. It's being squared, and so what I've got to do is square root each side. That leaves me with v initial equals v final squared minus 2ad, and I've got to take the square root of that whole quantity. So substituting, I've got to do my v final squared, which is easy, that's 0. And now I got to do 2 times negative 9.8 meters per second squared times my distance. I've got to take the square root of that whole result in there. So you guys go ahead and punch that into your calculator and you should get, oh geez. Sorry, can't tell from here. I was going to say something around 10, but it's not quite right. Alright, square root of 1,000, whatever that's going to be. Let's try the other one. So now that we have initial velocity and we have final velocity, you can use those to get your time. Just getting acceleration and time by itself, we got to subtract initial velocity from both sides. You'll end up with, let me move over here where we have a little bit more room. Final velocity minus initial velocity equals acceleration times time. Let's divide both sides by a so that you get your formula t equals v final minus v initial over acceleration due to gravity. So I will let you guys do this substitution in this box here. And let's talk about any questions you have in class tomorrow, since this video is already getting kind of long. Thank you very much for following along this far.